Have you ever wondered how the intricate parts of your phone or computer are made? Well, it all begins with the process of machining. Welcome to a journey through the fascinating science of machining and grinding. We begin with tool geometry, a pivotal aspect of machining. The shape and angle of a cutting tool significantly impact the mechanism of chip formation. This process is the heart of machining, where material is removed in the form of chips from a workpiece to achieve the desired shape and size. Alongside this, we delve into the mechanics of machining. This involves the forces acting on the tool and workpiece during the cutting process, which directly influences the efficiency and quality of machining. But, as with any mechanical process, heat generation is inevitable. This brings us to the topic of cutting temperature. From its causes and effects to estimation, measurement, and control, we'll explore how temperature affects the machining process and the role of cutting fluid applications in mitigating these effects. Now let's pivot to the life of cutting tools. As they are subjected to intense pressure and heat, they experience wear and can even fail. Our exploration of failure modes and wear mechanisms will shed light on how tools deteriorate and how this impacts their lifespan. In this context, we'll delve into the materials used for cutting tools. The choice of material can greatly influence a tool's durability and effectiveness, and consequently, the quality of the final product. Next, we move on to the mechanics of grinding, a subset of machining that involves removing material using abrasive particles. Understanding the economy of machining and grinding will provide insights into the cost efficiency of these processes. From there, we'll journey through special techniques and advanced technology in machining and grinding. The history of machine tool development also offers a fascinating glimpse into how far we've come in the world of manufacturing. Lastly, we'll touch on the concept of flexible automation. Explore the need, principles, and advantages of this approach, which uses computer numerical control, CNC, machining centers, and flexible manufacturing systems, FMS. These technologies have revolutionized the manufacturing industry, enabling faster, more precise production. So, to summarize, we've journeyed through the various aspects of machining, from tool geometry and machining mechanics to cutting temperatures and tool wear. We've examined the role of process parameters and cutting fluids in machinability, explored the mechanics and economy of grinding, and taken a look at the history and future of machining technology. Remember, the next time you look at a complex piece of technology, it all starts with the simple process of cutting and grinding material. With that, we wrap up our journey. Stay curious and keep exploring.